Hello students, welcome to Young Cubs. Today I've got a chapter of the 9th grade for you called Trigonometry. A lot of children have a lot of trouble with trigonometry, so let's first understand it from the scratch, from the basics. Okay, let me introduce trigonometry to you. So in trigonometry, children, there are three things, there are more than three things, but right now we will understand three things, which is sine, we will understand three things, which is sine, cos and tan. Okay, now like Pythagoras theorem deals only and only with right angles, here we will look at trigonometry with respect to only and only right angles. Alright? So here's my right angle triangle. Okay, let me name it A, B and C. We all know the longest side is known as the hypotenuse. Correct? We will find out more. For example, I have to find the sine of this angle C. Alright? And the formula to which is, for sine, it is opposite side upon the hypotenuse. Okay, so what is the opposite side to angle C out here? It is AB. So here it will be AB. And what is the hypotenuse out here? AC. Correct? Now how to remember this? For sine, there is an abbreviation. S for sine, O for opposite and H for hypotenuse. So for sine, it is always opposite upon hypotenuse. Alright? For cos, okay, cos of the same angle right here. Should I mark cos with green? So this is, I'm going to find the cos of angle C. For cos, it's going to be adjacent side upon the hypotenuse. Adjacent means the side lying beside it. So this is the adjacent side to C. What is it? BC upon hypotenuse, which is again AC. So the abbreviation for it is CAH, kah. Alright, for tan again we look for C. Okay, when we are looking for tan, it is always opposite upon adjacent. So opposite side is this, correct, which is AB. What is the adjacent side? BC. Understanding? So what is the abbreviation? T, O and E. TOA. I will show you the application of these very soon. Alright? But for right now, remember so, ka, toa. Let me write this right here on top. Or rather, let me first erase these. So here we go with the application of so, ka, toa within our sums. So our first sum says, in the figure 8.12, angle R, this angle R is the right angle of triangle PQR. Write the following ratios of sine P. So sine P means here. Okay, this part, this corner. Alright, so sine P, for sine it is opposite upon hypotenuse. So what is the opposite side? QR upon, what is the hypotenuse? My longest side is this, PQ. Correct? Find the cos of Q. So let's find cos of Q. Cos Q is equal to, what is cos? Adjacent. So this is the adjacent. What is it? QR upon hypotenuse, which is PQ. Alright. And what is tan P again? So go back. Tan P. What is tan? Opposite upon adjacent. What is the opposite side? QR upon adjacent is this one, which is PR. Easy, children. Let's find out T tan Q. Tan Q, this is going to be tan Q. So for tan Q, it is opposite upon adjacent. What is opposite to Q? PR upon adjacent, PR upon QR. Alright, children, this much is okay, this much is clear. There will be 4 sums that I'll be solving on the same basis so that you guys get it absolutely clear. Alright? Let's go to the next sum. Again, we write so ka toa, right? So in the right angle triangle XYZ, and the XYZ is 90 degrees, which is here, and ABC are the lengths of the sides as shown in the figure. Write the following ratios, that is sin x, tan z, cos x and tan x. Alright, let's do the first one. Sin x, sin is so what is x? This is my x. Alright, O is opposite is YZ upon hypotenuse is XZ, which is this one, correct? So if I have to write it in length, so YZ is A upon X, correct? Tan Z, what is tan? O is, it's tan Z, alright? So Z is here. Opposite is XY upon adjacent, that's my adjacent side, YZ, okay, which is nothing but opposite is what? XY. What is my XY? B upon YZ. YZ is A, correct? Cos X. Cos X is equal to, where's my X? Here. Cos X, cos is ka. Here we are, ka. So cos is X, so cos is adjacent, which is this, XY, which is equal to B upon hypotenuse is XZ upon C. Very simple. And what is it? Tan X. Tan X is equal to, what is tan X here? Opposite is YZ, which is A, upon adjacent, which is XY, nothing but B. Very simple, children. My third sum says, in right angled triangle LMN, angle LMN is equal to 90 degrees. Here's my LMN. Angle L is 50 degrees. So this is 50 degrees and angle N is 40 degrees. Okay. So find what, write the following ratios. So it is sine 50 t. Okay. So again, so ka toa, yes. So opposite of sine 50 is mn, mn upon hypotenuse is ln. Yeah. Cos 50 now. So cos is adjacent, which is this, which is LM. Hypotenuse is LN. Correct? This one. So for cos of 50, this is adjacent, this one is adjacent, LM, and LN is the hypotenuse. Very easy. What about tan 40 degrees? TOA 40. Opposite is LM. Adjacent is MN. Correct? And so this is my first one. This is my second one. This is my third one. And my fourth one is cos 40 degrees. Cos is ka, cos 40. So, this is MN, that's adjacent, and hypotenuse is LN. Last sum for today, children. In the figure 8.15, angle PQR is 90. PQR, this one is 90. Okay. PQS is also 90. PRQ is theta. This one very clearly marked, and QPS is PQR is alpha, and QPS is theta. Alright, so we need to find all of all. So let's look at first part. Sine alpha is equal to sine, so ka toa, sine, alright, sine of theta. So opposite, that is PQ upon hypotenuse, which is PR. Done. Second part, cos alpha, ka. So ka is adjacent, that is this one to the angle. RQ, this is RQ upon hypotenuse, which is PR. RQ, QR. Doesn't QR sound better? QR. And tan alpha is opposite upon adjacent. So opposite is PQ, and adjacent is QR. This one. Alright. Second part. Sin theta. Sin theta. Sin is again so. So here, now this is the second triangle, which is this. So this is my right angle, and we are looking at sin theta, which is opposite, which is QS upon hypotenuse, which is PS. Cos theta, adjacent, which is this, PQ upon PS, which is the hypotenuse, and tan theta, which is equal to opposite, which is QS upon adjacent, OR, which is PQ. Alright. Hope this much is clear, children. That's all for today. Thank you and God bless you all.